So on Friday, we went over the 5 different types of chemical reactions. Okay, we went over synthesis reactions, which is 2 elements combining to form a single compound. We went over decomposition reactions, okay, which is 1 compound breaking down into its elements. We went over combustion reactions, where a hydrocarbon, that is a molecular compound containing carbon and hydrogen, reacts or burns in the presence of oxygen, and it produces carbon dioxide and water. Right? We had some special balancing rules for those. It's that balance them in alphabetical order, and the rule of 2, where if there's an even number of carbons, we start the balancing with a 2. Okay? We'll go over that again today. Then we went over the 2 types of replacement reactions: single replacement and double replacement. The thing about replacement reactions is the compounds involved in them are always what kind? They're always ionic. All right? So in a single replacement reaction, we have an element, could be a metal, could be a non-metal, reacting with an ionic compound. That element will switch out with whatever part of the ionic compound it matches with. So if it's a metal, it'll switch places with the metal. If it's a non-metal, it'll switch places with the non-metal. Everybody follow me there? So what we'll end up with is a new element, okay, by itself, and a new ionic compound. In a double replacement reaction, we have 2 ionic compounds reacting with each other, and all we do is switch the metals, and we'll end up with 2 new ionic compounds as a result. Okay, ringing a bell? Yep. All right. So what we were asked to do with these here was we were asked to identify the type of reaction, write it out in words, which was really just a naming exercise, and then balance it. Okay, so we had to do kind of 2 things that were new and 1 thing that wasn't. So this reaction has an element reacting with an element to form a compound. What kind of reaction is that? It's a synthesis reaction. So we would just write synthesis. Okay. If I'm writing it out in words, what's this stuff? Nitrogen. Yeah, that's how nitrogen appears when it's in elements. Okay, we don't write dinitrogen, right? That's a very common mistake. This is how nitrogen looks when it's by itself. Okay, and it's reacting with hydrogen. That's how hydrogen looks when it's by itself, because it's one of those molecular elements. And that's going to react to form this molecular compound, which will be nitrogen trihydride. Okay, so again, just a naming exercise. Now we need to balance the whole reaction. Okay? Now on this side here, I have 2 nitrogens. How many do I have over here? Just 1. Now I can't just do this. A lot of people like to, oh, just do that. Except that's no longer nitrogen trihydride, is it? If I put that 2 in there, it changes the compound. I can't change the compound when I balance. I can only change how much of the compound I have. So where is that 2 going to go instead? In front of it, right? Okay, so now my nitrogens are balanced. But when I do that, there's now how many hydrogens? 6. So what needs to go here? A 3. Okay, and now the whole reaction is balanced.
You don't have to write those numbers in the word equation?
No, because it doesn't change what it is. It just changes how much. So no, I wouldn't have to go 1 nitrogen, 3 hydrogen, 3, or 2 nitrogen trihydrogen. We don't write the numbers in the word reaction.
Okay.
Yeah. Okay. All right. So the next one we have a non-metal nitrogen reacting with calcium chloride, which is what kind of compound? Ionic. Okay, and it's going to produce calcium nitride and chlorine gas. So, what kind of reaction is this? Single replacement. All right, so I'm just going to write SR beside it for single replacement. Okay, we'll write it out in words. We kind of already spoke it. Okay, so nitrogen plus calcium chloride and gives calcium nitride. Chlorine. Okay, and now I need to balance it. What should I start with? Calcium. Yeah, I would start with calcium. General rule is start with the biggest unbalanced number. Okay, and the biggest unbalanced number is calcium. So I'm going to go over here, and what am I going to put in front of calcium chloride? A 3, because there's 3 of them on the product side. All right, when I do that, that's going to give me how many chlorine? 6. All right, so I'm going to put a 3 here. That gives me 6 of those. I have 2 nitrogens here on the product side, and I have 2 on this side on the reactant side. So my reaction is now balanced. Good. Okay? We don't typically write ones in front of these unless it's a fill-in-the-blank question. Okay? If it's a fill-in-the-blank balancing question, put a 1 in the blank. Because if you don't, I don't know whether you finished it or didn't know what to do. Okay? Everyone follow? So if it's fill-in-the-blank, put 1s in front of everything. Otherwise, don't. What you cannot do, and I see people do this, is this. What does that say? You don't have any of that. Well, if I don't have any of that, I wouldn't have written it there. Okay? 0 is not a balancing coefficient. You will never write 0 in a chemical equation. All right? I'm only saying that because it comes up sometimes. Okay? I don't want to see people make that mistake. Okay, before we move on to some of these other things here. So I want you guys to try these two here. Okay, so looking at the third one here. Okay, so we've got in this one a compound containing carbon and hydrogen. It's reacting with oxygen and it's producing water and carbon dioxide. So what kind of reaction is that? It's a combustion reaction. All right. So the special rules for balancing these are, first off, balance in alphabetical order. And if there's an even number of carbons, start with a 2. Do I need that rule? No, 1 is an odd number. All right. So there's 1 carbon and there's 1 carbon. That was easy. Okay. Now I've got to balance the hydrogens. There's 1 hydrogen here and there's 2 here. So what needs to go in front of the water? A 2. Okay. Now that I have that there, I can balance my oxygens. There are 2 oxygens here, and there are 2 more in the water for a total of 4. So I need to put what in front of the oxygen on this side? 2. And now it's balanced. Okay.
What about like the subscript 4 by the H and then we get 1 hydrogens?
It did. There's 4 here, and now there's 2 times 2 is 4 there. Yeah. So yes, you're right. Absolutely. Okay. And then in our, sorry, we got to write this out in words. So this would be carbon tetrahydride. It's actually more commonly known as methane. Spark gas. Okay. So yes, theoretically you could light parts on fire. But if you did, you might burn yourself. Think about it. Okay. Okay, and then our next reaction here, we've got water as the only reactant. What's the only reaction we have that has one reactant? Decomposition. All right, so we've got decomposition reaction. Right, and now we need to balance it. Looks like hydrogen's already balanced, but oxygen is not. Okay, there's 2 oxygens on the product side, but there's only 1 on the reactant side. So I'm going to need to put a 2 here to balance my oxygens, which will give me how many hydrogens? 4. So I need to put a 2 here as well, and balance it. Right, so written out in words, that would be water, and water is the only thing you can use the common name for. Okay, we'll give hydrogen plus oxygen. Okay. Debbie, try the rest of these. There's 3 more there. Okay, so our next one here, I've got chlorine gas reacting with sodium iodide that's producing iodine and sodium chloride. So I've got an element reacting with an ionic compound. What kind of reaction starts that way? Single replacement. All right, so we got a single replacement reaction. And now we need to write it out. So chlorine plus sodium iodide. Here's iodine and sodium chloride. Okay. Next thing we need to do is balance it. Okay, what should I start with? I got a couple of choices. Right. 2. Yeah, I can start with iodine. I can start with chlorine 2. They have the same number and they're both out of balance, but we'll start with iodine. Okay, there's 2 iodines on the product side, but there's only 1 over here on the reactant side. So I'm going to put a 2 here to balance that. When I do that, though, it gives me 2 sodiums, and there's only 1 on the product side. So what do I need to put in front of this? Okay, when I do that, does that balance my chlorines? Always a good sign. Okay, if something you've done actually makes something else balance, it's a good sign that you're doing it right. Okay, because most of the time when you do this, balancing one thing requires you to change something else. So as you're getting near the end of the equation, your last thing should balance the last thing. Okay, or the last number you write in should balance the last thing. Okay, all right. Questions on that one? How many people have done the next one? Okay, all right, let's go over that one too then. Okay, so we've got calcium chloride. So we'll just write it out here. Calcium chloride, okay, is reacting with sodium carbonate. Okay, and that's going to give us calcium carbonate plus sodium chloride. Okay, what kind of reaction is that? Okay, double replacement. Okay. All right, so we got double replacement reaction there because they're all ionic compounds. You got 4 ionic compounds. That's the kind of reaction it is. Okay. Really here, I could balance either chlorine or sodium first. They're both out of balance and they're both the same number. And in fact, I'm only going to have to put one number in here because I'll balance them both at the same time because they end up together on the other side. All right, so I've got 2 chlorines over here, so I'm going to put a 2 there, which fixes the sodium problem I had. And there's 1 carbonate, right? This is carbonate. There's 1 carbonate. There's 1 carbonate over there. There's 1 calcium. There's 1 calcium. The rest is balanced. Okay, the last one. Okay, the very last one here is actually a super easy balance because it's already balanced. If there are no little numbers, everything is a 1. Okay, and so that's super easy because everything's a 1, right? In terms of the reaction type, it's double replacements, 2 ionic compounds and 2 ionic compounds. This is what we call an acid-base neutralization type of replacement reaction. HCl is an acid, KOH is a base, and you always get in an acid-base reaction water and a salt, okay, some kind of ionic compound. And it's always what you get in an acid-base neutralization. All right, so if we're writing this out in words, okay, we've got hydrogen chloride. Okay, reacts with potassium hydroxide. Okay, and that gives us water and potassium chloride. Potassium chloride. Okay, so that's one way that you could get reaction type questions, right? And each one of these would be out of either 3 or 4 marks. Okay, you'd get 1 mark for writing it out in word form. You'd get 1 mark for the identification of the type, and you'd get 1 mark for it being balanced correctly. If it was out of 4 marks, you'd got 1 mark for the reactants and 1 mark for the products in the writing part. Most of the time, that would be a 3-mark question. Okay? All right, the other way that you could get these would be I give you the word equation, and then you have to write the reaction in its formula form. Okay, that's tough. People make more mistakes doing it that way than they do if I give them the formula equation. Because if they don't get one of the formulas right, they also won't balance it right. In fact, they probably won't be able to balance it at all. Incidentally, if you are having trouble balancing a reaction you have written, it may be because one of the compounds is wrong. Okay, that's something you should double check. If you're having a really hard time balancing a reaction, double check that you've written all the formulas correct. All right, so that's the other way that could go. Okay, but that's more like this. Okay, so what I would like you guys to do right now, this is actually in your workbook, your digital workbook. If you want to have it on your phone closer to you, okay, this sheet is in there. Right, so call it up So I'll show you where it is. Okay, so it'll be in your classwork tab. And it'll be chemistry notes and workbook package. And it will be in the chemistry workbook package here. And this file right here, it says reaction worksheets, and it's the complete title is reaction worksheets with keys. Okay, if you click on that, it'll take you to the key version of all these worksheets. Right, so I would say do a couple and check the key. Do a couple more, check the key, make sure you're doing it right. Okay, don't do the whole sheet and then find out you've been doing it wrong and practicing it that way. Okay, so find the sheet, however, in here. Okay, in this file. And it should be the next thing after all the naming sheets. Which there were a lot of. Okay, there it is. Okay, so reactions worksheet number 1, equations and balancing. So balance the equation, write the word equation, write the type of reaction, okay, and sorry, that one's the other way. This is the part I wanted you to do. Right here, where I give you the word equation, and you have to write it out in formula form.
Are all the worksheets due at the end of the semester?
No, I won't check them. Yeah, they're just for you to practice with. Okay, you'll have enough stuff to hand in for marks for me as it is. No, I won't be checking any of these. All right, so let's have you guys try 1 and 2 for right now, just so we get an idea of how these type work, and then we'll go back and start the worksheet from the beginning. Okay, so on the last one here, okay, I wrote HOH, and I still called it water, okay, because it is, right? H2O, HOH. Either way I write it, it's water. It's 2 hydrogens and 1 oxygen. The reason we might write water this way is because in a replacement reaction, especially since we're getting the OH as an ion, okay, it's easier to track where it comes from, right? In a combustion reaction, it makes more sense to write water this way because hydrogen and oxygen aren't together like they are here, okay? But in a replacement reaction, it's easier to write water as HOH because then I can track where the OHs go and where the hydrogens come from, okay? It's just easier to kind of follow its origin. Right. Up to you if you want to do that, but I always do it so that I'm better able to balance and keep track of it. Okay. So I know I've kind of got this one written out already, but we'll go through it again. Okay, so we've got magnesium and chlorine. Right, so I'm going to write Mg, that's magnesium, okay, and chlorine. Here's where people make mistakes. They forget to look on their periodic table to check if chlorine is not just a molecular element, right, that comes as a 2, right? So oftentimes I'll have people write it like this, and then they'll go, oh, and that makes magnesium chloride. Okay, they drop and swap that correctly, and then they just go back here and do this. What do they get? Well, they'll get something for the products. The products are right, but their reactants are wrong. Their balancing is wrong. Okay, even though this equation is technically balanced, this is not the way the equation goes, so it isn't balanced. Okay, so it's really important to always double check with your non-metals to make sure that if you are dealing with, okay, a molecular element or not. So this one's actually a really easy balance because there's the mistake made right there, right? Whoever made this key screw up. Okay, not the way that one works. Okay, it should be Cl2. Okay, questions on that one?
So how come it's CO2 in that equation? Is that because we're like combining them?
That's just the way that chlorine comes as an element. Since it said magnesium and chlorine, we have to write them in their elemental forms. Okay, so magnesium is a single, chlorine. Okay, number 2, dihydrogen. Hydrogen. Dihydrogen oxide. I don't know why anybody writes it that way. It should be dihydrogen monoxide, actually, if they were going to write it as a molecular compound. But it's water. That's what that is. Okay? Gives off hydrogen and oxygen. This is like the 3rd time we've had this reaction. Okay? Now, this is another though example of, I have to remember that hydrogen as an element is a 2, and oxygen as an element is 2. Okay, say that in there because now you've got the word equation. There's so many more places where you can make mistakes going from words to formula. And so I say it's harder to do it that way. Right. All right, so we got to balance this thing. I have to put a 2 here to balance my oxygens and a 2 there to balance my hydrogens, and obviously that is a decomposition reaction. Okay, is that making some sense? All right, I'm going to give you a 5-minute break, and then we'll come back and start at the beginning of this worksheet. Okay, I think there are actually a couple of mistakes on the key, but there definitely is a mistake on the key for number 3 here, going from words to formula. The key is totally wrong, okay? So if we're looking at number 3, okay, we have aluminum. And why am I writing in this? Okay. Right here. Whoa. Okay. I'll do this right. Okay, so we've got aluminum and oxygen. So aluminum looks like this, right? It's just a metal. Oxygen is an element, looks like this. And it's going to form aluminum oxide, which is an ionic compound. So I have to drop and swap. This is a -2, this is a +3. So a 2 goes here and a 3 goes here. All right? Now, for the balancing on this, it can be a little bit tricky, because you've got some odd numbers and some even numbers in here. So what I generally do, okay, if I want to make something that's odd, even, balance, is I double the odd side. Okay, I've got a 3 over here and a 2 over here. Or I could just think of, like, what's the lowest common multiple of 2 and 3? 6. Okay, that's how you're going to balance things. So if I put a 2 here, that'll give me 6 oxygens on this side. And then I have to put a 3 here. That gives me my 6 oxygens. How many aluminum do I have? 4. So that's what the key should show, because that's done correctly. The key shows AlO3, which is not right. Okay? Yeah, that's not the right formula. Okay, so I've got a few people that are looking at number 8. They're running into some trouble with the balancing for number 8. Okay, so we're going to quickly have a look at that because it is a tricky one. Okay, so first off, what kind of reaction is it? Even that's tricky. It's a synthesis reaction. It's 2 reactants forming a single compound. All right, so it is still a synthesis reaction. It's just not your typical one. If we're writing it out in words, we've got sulfur dioxide plus oxygen gives us sulfur trioxide. Okay. Now, when we got to balance this thing, that can be tricky. Okay? If I'm looking at my oxygens, for example, right now on this side I have how many? 4. And on this side I have 3. Okay, what's the lowest common multiple of 4 and 3? Okay, that's what you have to do, especially when you have an element that is in more than one place on the same side of the reaction. So oxygen is in both parts of the reactants. That makes it trickier to balance. So I've got 4 on this side, 3 on this side. We just said the lowest common multiple is 12. So I'm going to make 12 oxygens on this side. And then I'm going to stop with the oxygens. I need to balance my sulfur right now. Because if I try and balance my oxygens, when I try and balance the sulfur after that, it won't work. Okay? So right now, putting that 4 there gives me how many sulfur? 4. So I'm going to back over here, and I'm going to put 4 in front of the sulfur dioxide. Now, I can balance my oxygens. Okay? And I have 12 oxygens on the product side. And right now, I have how many here? I have 8 here. How many more do I need? 4 more. So what do I put in front of this to give me? Right. If I put a 2 there, now I have 12 oxygens on both sides. 4 sulfurs on both sides. That's a tricky one. Okay? They don't get much trickier than that in terms of balance. Okay.
Can't you do it with 6 oxygens?
Yes, I can reduce this down, and you should. Okay? And that'll happen occasionally. You'll get it balanced, and then you look at it and go, oh, wait a minute. 4, 2, 4 could be 2, 1, 2. Okay? And it'll still work at 2, 1, 2. Okay? That happens sometimes, and you do want to reduce it down when you can. Right? It still works. I've got 2 sulfur on both sides. I've got 6 here. 4 plus 2 still works. Okay? All right. Any other ones giving us trouble? Don't be afraid to ask. Okay, okay.
I have 5 on the word one.
5 on the word. Nitrogen trihydrate. No? Okay, so for number 5 here, I've got nitrogen trihydride, so that's going to be NH3, reacts with oxygen, and it produces nitrogen and dihydrogen oxide. Water. Okay, now this is a tough one to classify because it doesn't fit. Like, this does not fit into any of the reaction types that we talked about. The closest thing to this would be a replacement reaction, except that NH3 is not an ionic compound, and I don't produce any ionic compounds on the other side. So I would never give you one like this on a test because it doesn't fit into our 5 types. Okay. All right. If we're looking to balance this one, okay, it can be a little bit tricky. I would say let's maybe look at the hydrogens first. I've got 3 on this side and 2 over there. Okay, lowest common multiple is 6, but if I put a 3 in front of that hydrogen, that's not going to help me very much, is it? No. Okay, because if I put a 3 here, it gives me an odd number of oxygens, and I can't balance that back over here. So, anytime I have that odd-even problem, what I do is double it. Okay? Because if anytime you double an odd number, you get an even number. Okay, so I'm going to put a 6 here instead. Right? And then, if I need to reduce later, I will. Okay? But at least I'll get it balanced. All right. So when I do that, it gives me 12 hydrogens over here. I'm going to go back over here and get myself 12 hydrogens. When I do that, it gives me how many nitrogen? 4. So I need to put 2 here. Now we'll look at my oxygens. There's 6 here and 2 here. So I need 3. Can't reduce this. 3 is an odd number. Okay. So now I'm good. I have it all.
For reducing, you have to reduce all of it.
Yeah, you have to reduce. Yeah, you have to reduce the whole thing. So it all has to be dividable by the same number. Like it wasn't with the sulfur one. Okay. Any other ones giving us trouble? Okay, keep going. Got about what 8 minutes left or so. So, think kind of getting an idea here of how this is going to work. Okay, we're going to start off with just kind of this stuff for a little bit. Then we'll start looking at predicting the products. Okay, where you only get the reactants, and you have to figure out what's going to come afterwards. Right. Tomorrow's quiz will be posted by 3:30 today. It will have some, but not much, some reaction stuff and probably still some naming. Okay, but I'll post it by the end of the day today. You can check it out tonight. Okay. Also, guys, make sure getting that lab report done, okay, for the night before, so that nothing bad will happen to you. Okay. Okay.